Hi, welcome back. The next topic is aspect-oriented programming in Spring. AOP is a very important component in the Spring framework. So what is the value add it does? One of the most common problems we come across in the source code is we see a lot of duplication code and the code is cluttered with that. For example, the best example is logging. So we see that the logging statements are being used in a number of places in the source code. So is there any way to make it better so that can we avoid the logging statements and can we improve the modularity of the code? Yes, it is possible. It is possible by making use of AOP aspect oriented program. See, AOP complements the object oriented program and it provides the additional way to modularize the code. In case of object-oriented programming, the basic unit is a class, but in case of AOP, the basic unit is aspect. So what does this aspect have? See, we were talking about one problem, which is logging, which is being done again in a number of places in the source code. Such concern, it is called as a concern. Such concerns are considered as cross-cutting concerns. You may ask me, can it be only logging? Not necessarily. It can be transaction management. Maybe you want to start the transaction, you want to end the transaction. And you want to do that in a number of places. So is there any way we can achieve the same functionality without cluttering the same code again in a number of places? Yeah, that we are going to explore. As already known, one of the key features of Spring is AOP aspect oriented programming. As already known, the basic feature of Spring framework is DI dependency injection, and obviously AOP is also dependent on DI dependency injection. As already said, there exists an aspect. So what is an aspect? An aspect is nothing but it is a class that has the concerns, like for example logging, for example transaction, or it not necessarily be a logging or transaction. It can be something which is related to the business logic also. So how do we identify that this class is an aspect? Means by using the annotation @aspect, or you can specify the same thing using XML configuration. So what does this aspect have? That we will see in the next section, that is advice. So what is an advice? An advice is nothing but it is a method inside aspect class. An aspect class can have a number of member methods which are supposed to get invoked from the business logic automatically. Business logic means that is the main logic where we are supposed to use these cross-cutting concerns. So now we want to separate the business logic from the cross-cutting concerns, that is logging or transaction handling or maybe anything else. And we want to place these cross-cutting concerns inside the methods which are available in the aspect class. So these methods which are defined inside the aspect class are termed as advisors. Now the thing is, we have the business logic and we have the aspect. Inside aspect, there is the advice. So do we need to invoke the advice manually from that business logic? No. If that is the case, it becomes an object oriented programming. It doesn't become an AOP. But our objective is to get these advices automatically invoked from the business logic without explicitly invoking. You do not want to invoke it, but you want to get it invoked automatically. For example, you want to put a log at the beginning of every method, but you do not want to invoke the advice which has the log. So how can we achieve means there is an expression for that. It is called point cut expression. So along with every advice, there is an expression. That expression says when this specific advice need to get invoked. So automatically that will get invoked. So you may be thinking, how does it automatically invoke? I'll explain about that in next few minutes. Now let me try to show that how it works. See, we have an aspect class. We have the join point. We are yet to see join point. Join point is nothing but it is the business logic which I was telling as a business logic. That is the join point. See, there are different advices like before advice, after advice. Before advice means before invocation of the join point method, this need to get invoked. That is before advice, and after advice. We will be exploring that in next few minutes. Now, let us assume there is a before advice. So what happens is here in the step 1, automatically the before advice gets invoked, provided the point cut expression is matched. What is a point cut expression? We'll see that. Basically, it is an expression which says where this advice need to get invoked. Does it need to get invoked for all the methods which starts with the name MET? Let it be for MET1, MET2, MET9, MET100. Then very simple, you have to put the expression, point cut expression as MET star. Or you want to end the name with MET star MET. Okay. So in our case, we can assume it as MET star so that it matches with the joint point name, that is MET1. So this is step 1. So after the advice is invoked, maybe there may be a logging inside that. It returns back, the control returns back to the joint point, and subsequently the remaining, whichever the business logic gets invoked. And in case you have configured a after advice also, it's not necessarily that before advice and after advice need to exist all the time. It may happen that you may want only the before advice, you do not want after advice, or vice versa. So after advice means after at the time of completion of execution of the join point, so that time you want to invoke this logic. Okay, right. So if you talk about a transaction, so you want to put this method inside the transaction. So inside the before advice, you can have the starting of the transaction, whichever the logic required for starting the transaction, whichever statements required. And in after advice, you can have the statements which are going to commit the transaction or roll it back based on your requirement. So let me try to show the same thing in the snippet of the code. Let me try to show this. Let me try to show the same thing in a code snippet. See here, I have a small example, and I have three different Java files here. So I'm considering this as the main application, that is the business logic. So here I am doing with a console based application. It's not necessarily that it need to be a console based application. Obviously it can be a web based. It works for web based as well. So just to keep it simple, I took a console based application. So here there is an employee class. This also comes under the business logic, just like main app. And we have the logging here. So basically the cross-cutting concerns are being specified here. So in our case, the cross-cutting concern is the logging. I do not want to use the logging again. I want to use it in one place, and I want that to get invoked automatically based on the matching method name or some other criteria. As we have already seen, I need to specify that this class is an aspect using the annotation @aspect. And I have two advisors here. This is one advice and other advice. Do not think that if there is a before advice, I need after advice. No, there is no such rule. It depends upon our requirement. If you want, you can have before and after, or only before. It depends upon our requirement. Now, what is the name of the method we need to give? It can give any name, it doesn't matter. So what matters is this point cut expression. So what exactly this is saying is, the first is the annotation, which indicates whether it is a before advice or after advice. And the second thing which matters is the pattern which you are using here. So what exactly it means, see, this means that the method need to expect int as a parameter. That is the join point. Okay. And the method name need to start with ACT star. Then only this is going to get invoked. This specific advice is going to get invoked automatically. Fine. Here I am putting dot dot star. Okay. The meaning of this dot dot means the join point may or may not take any parameters, and it can be any number of parameters. And we are mentioning star, that means for everywhere, wherever you are invoking a method, okay, wherever you are invoking the join point, so this need to get invoked, this advice need to get invoked. Now let's go to the main app. We are already familiar with this, how to create a bean, so I'm not going to explain that once more. It is the same thing which we have been exploring in the Spring Core. See here I'm saying get ID. Let me just try to comment all the lines, and let us focus only on the get ID. See, whenever you are invoking get ID, it invokes the get ID of the employee class. It invokes this. Okay, great. Now let's go and see which of the advisors are being matched. Does get ID match with this? No. So this before advice doesn't get executed in our case. What about after advice? In case of after advice, yes, it matches because it's telling any number of parameters and irrespective of the join point name. Okay. So after logging will get invoked. But am I invoking that after logging whichever from anywhere? I'm not invoking from anywhere. Am I invoking it? No. Okay. So the expected output is we will get this, and here at this specific place, after advice will get invoked automatically. So let me try to run the main application. So let me try to run this example. See, when you are running this example, actually we are getting set ID, set name, and we are not explicitly invoking it. So basically the Spring Core framework is invoking it. The reason is in the beans.xml, we are trying to set these values, that is ID and name. So 10 is being put to ID and somebody is being put to the name. And hence that is being invoked implicitly. So we can ignore that. So we are calling only the get ID explicitly. And after get ID, you can observe that there is a after login. Now let us go and make a small change to the point cut expression of any of the advice, and let us see whether that gets reflected in the output. So what change shall we do? So I'm going to put this after. So I'm going to change the parameter. I need it only if it accepts int as the only parameter. Fine. So anyway, this get ID is not accepting the int as a parameter. So I'm not expecting this after logging to get printed. So let me try to rerun the application. Yes, as expected, we are not getting that. So the main magic here is done by the point cut expression. And you may have a number of clarifications. Like for example, can this after advice or before advice get invoked only from one place in the business logic? Not necessarily. It can be in a number of places. Like for example, we are using get ID. So this get ID may be used in a number of places, that may be invoked in a number of places. Or it need not be get ID, it can be some other business logic. The only criteria is the matching point cut expression. Now, let's go and explore the terminology a bit. So we are already, now let's go and explore the terminology a bit more. We have already seen what is an aspect, what is an advice. Now let us see what is a joint. As I already told you, a joint point is the business logic method. That is, it is the point from which our advice gets invoked automatically based on the matching point cut expression. So in our case, in the example which we have just seen, get ID is the joint point. That is the place from where the advice is getting invoked automatically. So how it happens automatically, we are going to explore that in the next few minutes. Next, what is target object? They are the object on which advices are applied. Okay, see what I would like to share is, there is an object which is being created by the Spring framework on the fly in the runtime. So I tried to show that in one of the diagram. See here, if you see, we have an employee class. So actually, Spring container is internally creating one more class in the runtime. And that class, let us assume the name of that class is proxy employee. It extends from the employee. And here the methods are overridden. Similarly, our get ID, which we have used, that is being overridden. And based on the point cut expression, one or more advisors are invoked appropriately. So we are not writing the code of invoking that logging. Spring is writing that for us. So what is the advantage? Our code is not cluttered with the routine cross-cutting concerns. That is the advantage. So it improves the readability, maintainability, etc. So this specific object of proxy employee is considered as this specific object of the proxy employee is considered as the target object. So that is being created on the fly. So AOP proxy is the proxy class which is being created. So the proxy class is the proxy employee which is being created. It is created in the runtime. Who creates for us? The Spring framework creates for us. Here, the proxy design pattern and the reflection is being applied. See, this process of combining, weaving happens in the runtime, and it is the process of linking aspects with the target objects to create the advised proxy objects. So the process of combining all these is considered as weaving. See here, before advice gets invoked, then we are returning. After that, after advice is invoked. So this process of combining is considered as weaving. This process of linking is considered as weaving, and it happens in the runtime. So the small disadvantage of AOP is there is a small performance hit because the proxy object. Now let us see what are the different types of advisors which are available. We have seen before advice and after advice. Before advice is the advice which gets executed just before the join points is executed. And after advice is executed after completion of execution of the join point. After throwing advice is there, that gets executed only when the exception is thrown from the join point. There is after finally advice. So this gets executed whether there is a normal return or exceptional return from the join point. And there is one more advice which is around advice, which is very powerful. See, around advice can use the custom behavior before as well as after the join point. And it is so powerful that it can also check in the runtime whether to execute the join point or not. Next, let us explore one more application which is using Spring AOP. See, here we have an application. So first, let us take a quick look at the pom.xml to find out what are the main dependencies. So if you take a look at this file, pom.xml, so the main dependencies here you can find the Spring context, and after that this aspect J related dependencies. So these are the prime dependencies. So the example code is shared with you. You can explore it further. Now let's explore the source code of this application. So this is the main driver of this application. So it's a console based application. So wherein I'm trying to read all the bean related information from the beans.xml, and here I am requesting for a bean with the name student, that is the bean ID. So if you go to the beans.xml, you will have the student. The class is student. So basically the instance, that is the bean of that, is being created by the Spring framework, and we are given the reference to that. And we are further invoking some of the methods. Okay, so here I kept it intentionally. In case we are directly creating the object, we create it like this. But here we are dependent on the Spring framework to create the object of the student and give to us. The reason is we get all these advantages of AOP and all that. By any chance you directly create it, then the AOP functionality doesn't work. You may try it out by commenting this above line and uncommenting this line and try to do all this. Verify that the AOP functionality does not work. Right. Next. Fine. So we are invoking some of the methods with the student object. Now let me go and take a look at the aspect. See, here we have two aspects. One is logging.java and the other is logging underscore old.java. So let me go and check in the beans.xml whether I'm considering both the aspects or only one of them. So here if you see, I have commented the logging old. So basically only this logging is active. So if you go to this logging.java, I have the aspect, the name of the class is logging, and I have some advices. We are already aware of the different advices which are available. One is before advice, after return advice, and around advice. These are the advices. So here we have a before advice, and the point cut expression says that, see, what is the meaning of this point cut expression? Dot dot means this before advice is being applied to all the methods irrespective of the number of parameters. Here star means it can be any method name. If there is any specific pattern, you can specify the pattern here. This says any class name or any package, and this says it can have any access specifier. So that is the meaning of this point cut expression. See, if you see in the previous example, we were not getting this join point, and we were just trying to print some log and return from that advice. But here we are getting the join point. So it's optional. So if you specify it, then the Spring Framework injects this join point to you, else not. So as we already seen in the terminology, join point is the point from where this advice gets invoked. Okay. So why we need this means, let us assume you need the details of the join point, like for example, which were the parameters which were being sent to the method from where this advice is indirectly invoked or automatically invoked. So you need all the parameters, or you need the name of that method, or you need the name of that class, etc. So how you can retrieve is by using the join point. So if you see here, I am trying to print the name of the method. Okay, so if you see here, I'm getting the signature of it, and further I'm trying to get the name, and further I'm getting the class where it is in and the name of the class. So now let's do one thing. To keep it simple, I'm going to comment all the other advices and let us see how this advice works, and further if we can explore the other things. So I'm going to comment all this. Now let me run it. By the way, this specific join point is being applied to all the methods. The reason is we gave star star everywhere. Okay. So let me try to run it. Let us check what exactly is being printed when this advice is being invoked from different methods, that is different join. So here the first, I think the flow we will be getting from the main application. So I went to the main application. So here the first thing is I am invoking the set name. So the control goes to the set name. So the control goes here. So this is being printed like set name colon argument. But in the before advice, I am trying to print some details about the join point. So if you go here, see this is being printed. After this is printed, I am trying to print the join point name, that is the method from where this advice has been automatically invoked. So the output for this is set name. And further, I am trying to print the name of the class where this join point is located. I'm trying to print it. And if you go further, here I am trying to get all the arguments into an array, and you can just improvise this logic wherein you can iterate through this array and print all the parameters. Even you can try to do that. Now what I'll do is I'll just try to uncomment this small part and let's see how it works. So I need to run the main application.java. If you see here, it's printing parameters argument. That means I am able to print the parameter which you are trying to send here. But here what's happening is you are trying to print only the first argument. It is possible that you can try to iterate over this array and print all the data. Anyhow, I'm just trying to comment it. The reason is it's trying to cause a crash whenever the first parameter is not available. So just to avoid that, I'm trying to comment it. Anyhow, you can improvise this logic. So basically, you can try to get any detail about the join point. Okay. Say for example, you have a log at the beginning of the method. You want to print the method name followed by all the parameters which are being received. So you can very much do that here. Okay, right. Now let us try to uncomment the other. So I'm going to uncomment next after returning. So after returning, yeah, it is a after advice. So basically this is also being applied to all the join points. Here there is some speciality, like something like the return value. That means from the join point, whichever value is being returned, so I am capturing that in the ret value, so which I am actually trying to print here. Okay, fine. So let's go to the main driver of the program. So let us check if anything we had put here in the get. Yes, get name we have put this, and in the get age also we have put this. Okay, fine. So now let's go to the main method and just try to run it. So here we have, this is the get age and we are printing 20. That is fine. But we are interested where exactly we are taking that return value and printing as a part of the advice. So that is the interesting point for us. So do we have returning anywhere here? No, we do not have it anywhere here. Let us check why that is not being invoked. Now let us try to uncomment the other advisors. So as we see here, there can be any number of before advisors or after advisors, and each one will be having a different point cut expression based on our requirement. So here if you see, like we have two at the rate before advisors and we have one at the rate after advisors. So basically this advice is being applied only for the methods which is accepting any number of arguments, and the method name need to start with get, and it can be in any class and it can be in any package. So the same thing here. Fine. So let's try to run the application. So as we see here, this before advice is getting printed, after advice is getting printed. Fine. So, but that is being applied only for the get star method names. Fine. So similarly here also, if there is a need, you can get the join point and you can further extract more details of that join point, and you can use it for printing purpose or to perform any other processing in the device. The same thing here as well. So I have just added after throwing advice. See, basically I want to capture when an exception is being thrown anywhere in the business logic. Like here, I give the point cut expression as for all the methods in all the packages, which accepts any number of arguments. So whichever the exception is being thrown, I'm capturing it with the name exception. So thereby, I'm receiving it as a parameter, and further I'm displaying it, or I can do any other processing with that. See, let us assume we have a very small requirement, like something like wherever the exception is being thrown, I just want to capture it and I want to send a mail to the team, DevOps team. So instead of going and cluttering the code everywhere, so I can just try to do this. So you can achieve this in a matter of few lines rather than going and changing the code everywhere and cluttering the code. Now, so I just executed it. So you can see that the output, like inside after throwing advice, you can see here, and the exception details also you can see here. Now let me just try to uncomment this. Let me try to uncomment the around advice and Now let me try to uncomment the run advice and rerun the main application. So as you see here, this around advice is called a number of places. Fine, because for everywhere, whenever a joint point is being invoked, so here we see a match with this point cut expression, and hence this gets invoked for every joint point. Now let us explore one more example wherein we can use alias names for point cut expressions. See, if you see this specific example, here we are creating an alias for the point cut. See, we will be needing this specific point cut in a number of places. So what we are doing is we are creating a alias name for these, and we will be reusing wherever required. Say I need the same point cut expression here, so we will be using this setter pt cut, and I will be needing here as well. And yeah, that's it. And again here we are creating one more alias name for this specific point cut expression, and we are using it in multiple times. So this is one more feature of the point cut expression. And one more thing is, see, we have seen three different after point cut expressions. One is after, the other is after returning, the other is after throwing. So what is the difference means? After gets executed once you are returning from the join point. After returning is executed only if you successfully return from the join point. And after throwing is executed only if an exception is thrown within join point. Now let us just try to run this example. See, here we are getting an exception. Let's go and explore what exactly is it. Did we manually throw it, or we are getting because of any other issue in the configuration file or in our source code? See here, if you see, it is saying that can't find referenced point cut getter. See, whenever you get an exception, you go to the first line and you can read it completely. Generally, you will get at the last part of the first line. Fine. So here, the reason is there is a mismatch between the point cut alias names and wherever. Okay. So here we are trying to refer, if you go to these lines, we are trying to refer as a PTCUT, but I gave some other alias name for that. So let me try to change it. Fine. Now let's go ahead and run this once again. Yes. Okay. So that is about the point cut expressions alias. So before concluding this part, let us explore some points. So how many aspects we can have in a project? We can have any number of aspect classes based on our requirement. The only thing is you need to annotate that using @aspect. And in one aspect, you can have any number of advisors. You can have multiple before advice, multiple of after, multiple of after throwing. So based on our requirement. Yes, that's it about aspect oriented program. See, one more point is We can also have the configurations specified as a part of the XML file. See this aspect and before advice, after advice, all this you can very much specify even in the XML configuration file. So I'll be providing this example. You can just try to refer. Conceptually, everything same. The only thing is instead of using annotations, we'll be specifying aspect and all the advices in the XML file. And here you will just be the aspect will be just a normal Java file, and all the annotations are being specified. The details which are in annotations are being specified in the XML configuration file. So that is the only difference.